It'll either eat or it won't.
All right, good morning, everyone. It's Thursday, right? So some housekeeping stuff. If you're just coming in, your quizzes are up here. You come grab them. Anybody else need them, come grab them, and then I'm going to pick that stack up. Today we're going to finish 3.1, start 3.2. Our first exam is 2 weeks from today. And there is a question about what's on the calendar. The schedule online says that it only covers 3.1 through 3.5 at 4.3 and 4.5. Actually, it's going to cover everything we've done because we won't get through all that material. So starting at R2 through wherever we get. And I'd say wherever we get by the end of next week, okay, is what will be on that test. So next Thursday, wherever we stop, that's where the test material will stop. What we cover on that next Tuesday we meet, before the test, will not be on the test on Thursday. All right? What else? Quizzes. So I've graded the quizzes, and I put the grades on online, so you should see that reflected on your score. If you have below 50% for both quizzes, I highly recommend that you meet with me. Do something. Take the initiative to contact me. I was thinking about saying if you have an average of less than 50, everyone that's in that group is going to stay behind. I'm going to end class 10 minutes early and we're going to have a discussion. But I decided I'm not going to do that. I'm going to put it in the ball's in your court. Okay, I want to talk to you about, before we get too far into this, if you struggled on these first two quizzes, I'm concerned about it. So let's do something, right? Let's make a change. Any questions before I begin today's stuff? We're good? What I saw in the quizzes is about half the class knew what to do, and about half the class didn't know what to do. It was about split almost 50-50. So, that's kind of my worst nightmare is to have that huge split in a class because it's hard to teach to the middle of that when you have students that get it and you have students that don't. So that's why I want you to come to me so we can figure out a plan for you, all right? So we can figure out what we need to do to get you up to speed. All right, so we did difference quotient last time, right? How was that homework? So y'all know the online homework system you go to get to the homework? It shows me that only 16 students are registered. And I'm not sure if that means that only 16 students have actually logged into the homework or not. That's kind of terrifying if that's true. But I think the only way to get in there is to register, right? Like when you logged in, no? It lets you into the ebook? So, okay, so if you did, okay, good, that makes me feel better. Because I was like, you just have to register to let you in. Okay, that makes me feel better. I think some of you might have registered and that's fine, but I was like, oh my gosh, if only 16 people have actually looked at the ebook, oh no. That kind of explains maybe why half the students did that, but okay. All right, so difference quotient, homework. Hopefully you had some time to go over that. We're going to continue today, and we're still in 3.1. We're actually, if we follow the order of the ebook, we skipped ahead, and now I'm going to go back a little bit. So I have this new TV that they put in here, so I've hooked it up where, I don't know if that's any better, but at least you don't have to look over there. I've got two different screens, so I'll tell you to look there if I want you to look there, and I'll tell you to look here. Unfortunately, this will not be on camera, all right? So this is what we did last time, right? Can I touch this? No, it's a touch screen, but I have to control it from here. Okay, so we did difference quotient. Now what we're going to do is we're going to talk about so the difference quotient was an operation that we're going to need to be able to do in calculus, right? I told you that. But we're now going to look at what we call the arithmetic or the arithmetic operations of functions. All right, so I'm going to put this up here. We are covering this 3.1, the arithmetic operations between functions. And I want you to look here at that letter at the end of that. Functions implies what? More than one, right? Functions, plural, right? So when you're learning about numbers, right, in grade school, right, elementary school, you learn about numbers, you learn how to what? Add them, subtract them, multiply them, and divide them, right? Those are what we call the 4 arithmetic operations. So arithmetic operations are addition, subtraction, remember those old school symbols, multiplication, division? Those are your 4 arithmetic operations, and we learn how to do that with numbers, right? Now what we're going to do is we're going to do the 4 arithmetic operations with functions. And really, students really don't have a lot of problems with the idea of what we're doing. It's going to come down again to the same shit that's been driving you crazy from the beginning of this, and it's the algebra of simplifying things. That's what's going to be the trouble, right? So let's start off. We're going to start with 2 functions, and then we're going to add them, and then we're going to subtract them, and we're going to multiply them, divide them, all right? And so first, let's get the notation down. The first note here is the sum, right? The sum of 2 functions. So if you're given 2 functions, you're given f and g. Now notice I wrote f and g. I didn't write f of x and g of x, because remember, f and g are the names of the functions, all right? So I'm giving you 2 functions, f and g, and we want to find the sum. We want to find the sum. Well, how do I tell you that? How do I tell you, hey, look, I've given you these 2 functions, add them together, right? Well, this is the notation that we use. Okay, the notation we use is this. We write in parentheses f plus g, close parentheses, then we do the parentheses with the x in it, and this is the notation right here. This tells you, hey, add the 2 functions together. Makes sense, right? So what is the name of this function? Because remember, the notation I told you all last class we use is that if you write this, right, that's a function. What's the name of this function? F. No, not f of x. F is the name of the function, all right? F of x is the value of the function at x. Those are 2 different things. So the name of this function is f. It's the thing in front of this parentheses with the x in it, right? So what is the name of this function? F plus g, okay? The name of this function is f plus g. And what it is exactly what you would think. It is take the 2 functions and add them together, right? And when you add things together, order doesn't matter, does it? Like if you switch that, it would still be the same answer. All right, that's the sum. All right, now let's do the difference. So if I want you to do the difference of 2 functions, right? If I want the difference, same thing. If we're given f and g, how do I tell you that I want you to subtract? Well, I'm going to use the same notation. I'm going to put f, but this time minus g. And so the name of this function is f minus g. And all it is exactly what you would hope it is, and that is you take the f function and subtract the g function. Now, does the order matter here? With subtraction, can you just flip things and everything's still the same? No, right? I mean, you think about numbers, right? If I do 5, take away 3, that's not the same as taking 3 and subtracting 5, right? Those aren't the same. With addition, it is. With subtraction, it's not. So when we say f minus g, we're saying take the f function and subtract from it the g function. If you want to do it the other way around, I would write g minus f, right? Good? Notation, I mean, notation usually makes sense to people, yes? Okay, what about multiplication? For multiplication, the notation is this. Parenthesis, all we do is write f and g next to it like that. That's it. Now, it's implied that there's a multiplication in there. And of course, as you would expect, that means you take the f of x function and you multiply the g of x function. This is all in the online ebook, right? There's the subtraction or difference, there's your product or multiplication, and then the quotient, the last one, right? This is division, we call that a quotient. I'll put here product as well. just in case. And then quotient is division, right? We write f over g in parentheses of x. And then it's, again, what you would think. You take the f function, you divide the g function. The order there matters, right? What's in the numerator and denominator, you can't just flip them. It's going to change the answer. So there's one little thing on the end. Do you see that other little thing on the side? What is it saying? G of x can't be 0. Does that make sense to you why this can only work as long as the bottom function is never 0? Because if the bottom function is 0, you have problems, don't you? Okay, so those are the 4 arithmetic operations with functions. With numbers, right, we have those 4 as well, right? There's actually a 5th operation with functions. We're not going to talk about it yet. We're going to talk about it later. But there's a 5th one. You can do it with functions, but you can't do it with numbers. So we'll get to that. All right, so let's just do an example. In your homework, let me see if I can bring this up easily here. In your homework, there's a set of questions. Where is it? Right here. It's numbers 71 through 78, and I told you to skip those, right? I told you don't worry about those right now. Let's do one of those. So let's start with something pretty straightforward. Let's do number 72. So for number 72, you're given f of x equals 2x plus 1. And then they use a colon, okay. And then they give you that g of x is 3x minus 2. So my first question to you is, are these both functions?
Yes.
How do you know?
The notation.
The notation I'm using tells you it's a function, right? You don't even need to think about it. The fact that I wrote f of x tells you it's a function. The fact that I wrote g of x tells you it's a function. This one, the name of this one is g, the name of this one is f. Okay, we're going to do parts A through D here. I hope you all can all see that. So we're going to find the sum, then the difference, then the product, then the quotient. After we do that, then we're going to take the sum and we're going to plug a number into it. And then we're going to take the difference and plug a number into it. The product, take a number, plug it into it, and then the quotient, take a number, plug it into it. So let's do part A. We're going to find this. All right. Let's see. So this, by definition, just means you take the f of x and you add the g of x, right? So that's just the definition of it, right? And that just means take your f function, which is 2x plus 1. I like to put it in parentheses and then add to it, what, 3x plus 2. Or sorry, minus 2. Right? There's your f function, adding the g function. Did I really need the parentheses? No. Why? I'm adding, right? And so there's like a 1 in front of this, which changes nothing, right? And this is like a plus 1 in front of this, which changes nothing. So I didn't need them, the parentheses, but that was just to stress that we've got f plus g. So I can drop the parentheses completely. 2x plus 1, plus 3x minus 2. And now I collect like terms, and I get 5x, take away 1. So what this is saying is that, let me try and get you to understand this visually, because I think this is important, all right? So what we're saying here is that if you look at the f function, right, it takes something in, right? The f function takes an x, and it spits it out here at 2x plus 1. That's what the f function does, right? The g function does something different. The g function takes an x and spits out 3x minus 2. What we have found is a new function, right? This is a new function. It's f plus g. And what it does is it takes x in and spits out what? 5x minus 1, right? 5x minus 1. So let's wrap our heads around this. Let's take a specific number. What number do they want us to plug in? I'm going to jump to E right now. What's f plus g of 3? So let's start up here, right here. This is our function, right? So if I ask you what's f plus g of 3, all I'm saying is plug 3 into that, right? Into that sum. So 5 times 3 minus 1, which is 14. Okay, so what did this combination of functions do? Well, come to this one, plug 3 into this. What would happen if you plug 3 into f? 7, right? And then what if you plug 3 into g? 9, take away 2, you get 7, right? What's the sum of those two answers? 14, right? So what this, putting them together algebraically, what it did is it does all of that for us. So we don't have to like think about each one individually. We can think about them as just some new function, all right? So with the arithmetic operations, we start with two functions, we do some arithmetic, and we get a new function, right? We get a new function. Y'all got it?
Is that a way to check your answer?
You could check your answer. It's just a little tedious. All right, let's do subtraction now. All right, so let's do part B. Can I erase? We're good? You have a question? Oh, yeah, you don't have to ask. What if I said no?
You have a very bad day.
I think you'd have a bad day.
Yeah, we'd all have a bad
We'd all have a bad day, and there we go. All right. All right, so now I'm going to do subtraction, part B. So I'm going to take f of x and subtract g of x. Hey, just real quick, can you guess as to what the answer would be to this if I plugged in 3? Because you're subtracting the 2 now. Well, we know that when we plug 3 into this, we get 7, right? And 3 into this got 7. So if we subtract those, we should get 0, right? Okay, I'm just thinking about it. Okay, now I'm going to put the parentheses around this, 2x plus 1. I'm going to put minus here, and then 3x minus 2. So I'm taking my f function, subtracting my g function. Now the parentheses were important, weren't they? Because I have to distribute this negative through to these two terms. This parenthesis wasn't necessary, right, because I have a 1 in front, but there was no harm in putting it there. So 2x plus 1, what? Minus 3x plus 2. So I'm distributing that negative through, right? Combine like terms, negative x plus 3. That is our difference function, right? That is the difference of the two functions. With me? Just for the, I'm not going to do part F. Part F asks us to plug in what? 4? Let's plug in 3 instead. What if you take the difference and you plug in 3? So plug 3 into the answer you just got, and you get 0, right? Which again, the idea is that if you plug 3 into F, you get 7. If you plug 3 into G, you get 7. And if you take this 7 and subtract that 7, you should get 0, which is what that function does for us, right? All right. Addition, subtraction, done. Multiplication. Multiplication. So part C. If we write f and g next to it in parentheses of x, this means we're going to take the f function, we're going to multiply it times the g function, which for us is the f function is 2x plus 1, and the g function is 3x minus 2. So I have a student that writes it that way, and then I have a student who writes it this way. What's wrong with this? There's no parentheses. So if you had to do this, right, if you tried to simplify this, the only multiplication you're doing is those two, right? Right, that's what this means. You're just multiplying those two together. So this would just be 2x plus 3x minus 2, and that's just 5x minus 2, right? That's what that is. So no parentheses there means this. That means we have to have the parentheses here for this to work, for us to truly be multiplying f and g together. And if I have parentheses there, right, if I have parentheses, then that means I'm going to need to do what? FOIL or expand, right? So I have to multiply here to here. What's that? 6x squared, here to here, minus 4x, here to here, 3x, here to here, take away 2. Combine like terms, 6x squared minus x minus 2. There we go. So what does this function do? What does this new function do? It takes the two outputs, right, and multiplies them together. So what should I get if I plug 3 into that? What should I get? What happens when I plug 3 into this? 7. 3 into this? 7. What happens if you multiply those answers? You should get 49. So when I plug 3 into that, I better get 49. Make sense? Let's try it. That's f times g of 3. So plugging into that, I get 6 times 3 squared minus 3 minus 2. I'm just replacing all of my x's in here with 3's. Order of operations, right? Square the 3 first. 3 squared is 9, right? 9 times 6 is 54. Minus 3 minus 2. And if you do that, that's 49. So I hope this is making sense to you, both the algebraic manipulation of this along with what's really happening. It's like we start with two functions and we're creating this new function that does some operation for us so that we don't have to do them separately each time. It's kind of like kills two birds with one stone. We all right? Can I keep going? All right, division, quotient, I should say, quotient. So for quotient, this is, wait, was that C or D? Who cares? This is D. Let's do f over g of x. This means we take the f function and we divide by the g function, right? Any ideas what we should get if we plug 3 into this? 1, right? Because if we plug 3 into this, we get 7. If we go 3 into this, we get 7. If we take that and divide by that, we get 7 over 7 is 1. So that's what should happen if we plug 3 into this. But we got to get what it is first. So f is on top, 2x plus 1, and g is on the bottom, which is 3x minus 2. Now the good news about this expression that we're looking at here is there's nothing we can do to simplify that. Like we can't cancel x's, can't do anything else. So we're done. This is it. This is the answer. But there is one little thing we have to pay attention to. And that is, remember on the formula, we had that thing on the side that said when we get to quotient, g of x can't be 0? Right? Remember that little thing that said that? We have to look at this and we have to ask ourselves, wait a minute, hold on, would that ever be 0? Could that ever be 0? So I'm going to just ask myself, what would make that 0? So I'm going to set the denominator equal to 0 and solve that for x. And if I solve that for x, add 2 to both sides, divide by 3, we get 2/3, right? So what I know right now is if I try and plug 2/3 into that, I'm going to have division by 0, right? Can you plug 2/3 into this? What would happen if you plug 2/3 into this? Would that be okay? Would you get a number? Yes? What happens if you plug 2/3 into this? Would you get a number? Yes. But you would get 0 here. That's not a problem, right? If I ask you to plug 2/3 in here and you get 0, there's no problem with that, right? But if you're looking at the quotient, then there is a problem, because if I try and plug 2/3 in right here, I'm going to get 0 here, and division by 0 is not defined. So you would have to explicitly state here for this one that f over g is this, and you would have to put for, or something like that, for x not equal to 2/3. Did I say 3/2? I said 2/3? Okay, it's 2/3. All right, this is our quotient function so long as x is not 2/3. Because if it is, it's not defined. Do you get the basic idea? These were nice little functions. We're going to get to more complicated ones in a second. Yes?
Do you have to solve for x every time you come that part?
Anytime you have a quotient, you always have to ask yourself, what makes the denominator 0?
Okay, that's what. Okay.
Yeah. And we're actually going to talk, we're going to step away from this a second because this actually brings us to another idea in this section that we have to address, which is domains. See, this is our first kind of like, well, wait a minute, there's some values of x that could cause a problem, right? And that brings us to this concept of a domain of a function. So that's what I'm going to transition to now. Once we cover domains, we're going to come back and do more of these, all right? All right, so I'm transitioning to a new topic. It's connected to what we're doing here, but I need to get like a formal treatment of it first. Yes.
Would you expect us to write x is not equal to 200? Like, would you expect that on the test?
I will ask you what the domain of the function is. So you will have to tell me what can't be in there. Yes. Domain of a function. All right. So look, we already said from last class, right, just as a recap, that a function is a relationship between two things, right? And what we need is that when you have something here, that as long as it goes to one place over here, then it's a function. What we can't have is this, right? This was what would be a problem, right? That's bad. This is bad. This is no longer a function, right? That's what a function is, right? Something that takes something and sends it to exactly one place. And we even talked about this. Was this okay? That was okay, right? We just couldn't have one thing branch off to two things. That's what a function is. But functions, right here, the things that you plug in, right? The inputs, for us are numbers, right? In this class right now, the things we plug in are numbers. Not every function can handle every number that you give it. So I like to give the analogy of like a car wash. If we think of, you know those car washes that you can drive through, right? You take your little car, truck, whatever you have, right? That's a truck, obviously. Okay, so you take it, it's all dirty, right? Comes through, goes through the function, which is the thing that cleans your car. It comes out all shiny and nice over here, right? Okay, that is a function. The input of this function are dirty vehicles, right? The output is clean vehicle, right? If it's a good car wash. But there are certain vehicles you can't plug in, right? Like most car washes cannot accommodate an 18-wheel tractor trailer, right? So that would mean that there is a domain restriction for this function. There's certain things that it can handle, certain things that it cannot, right? Yes?
Is it when you write x is equal or like less than or greater than all real numbers, something like that?
That might be a way that we define a domain. There's different ways to write what the domain is. And we're gonna do that. We want to first understand the idea of a domain is that when we're dealing with functions, right, we have numbers go in. These are numbers. It's not a hashtag, right? That's the number symbol. Numbers, right? And our function does something and spits it out over here, and we have another number, right? So domain restriction is saying, are there certain numbers we cannot plug in, right? Are there certain things we can't plug into the function? And in this class, all right, in this class, for college algebra, there are two major domain issues that we look at, okay? The first one is division by 0. That is something we always have to pay attention to. Does our function ever have anything that makes the denominator 0? Didn't we just see that just a second ago? X was 2/3, made it 0. So we always want to be looking at functions and asking ourselves, is there anything that would give us division by 0? That's the first thing. The second thing in a college algebra class that we look at is anytime we have a root or roots. Sorry, I missed something right in front of that. Hold on. Even roots. even roots. So what I mean by that is if we have a square root, or if we have a fourth root, or if we have a sixth root of something, what can we not have underneath that root? A negative number, okay? We cannot have a negative number under here. So I'm going to put a little negative here and circle it, negative circle, negative circle. This is bad. If we ever get a negative under a root, why can't you have a negative under a root? We talked about this a little bit. Why can't we do that? It brings in the imaginary numbers, right? And I said, right, you don't see imaginary numbers till way later. So those are the two issues. In college algebra, those are the only two things you have to worry about. Now, as you proceed through the STEM sequence in math, the amount of things you have to worry about increases. You start to get more things you have to pay attention to. But here, there's only two, all right? Those are them, all right? So I'm going to now give you some functions, and we're going to talk about the domain. So I'm scrolling up here, and we're going to go, now we're in the homework, we're backing up to 51 through whatever. So let's take a look at our first function here. And let's go with number 52. The question here is to find the domain. And so when someone asks you to find the domain of a function, there's two different ways you can respond to it. There's two different ways you can respond. You can either tell me what I am allowed to plug in, or you can tell me what I am not allowed to plug in. But you need to be clear, all right? You either say, yes, this function, the domain is, you can let x be this, or you can say the domain is you need to make sure that x is not this. It's one or the other. And both of them are okay, acceptable. So let's look at this. X squared plus 2. Right? This is a function. How do I know? Because the notation tells me it's a function. All right, so I'm asking myself first, by looking at this, will I ever get division by 0? Well, you don't even have a fraction, do you? I mean, you don't have a fraction where your variable is in the bottom, right? So you're never going to have division by 0, ever, right? Do you see an even root? Square root, fourth root, sixth root? No, right? So that means this function should be able to handle any number I give it, right? Just think about it. Plug a number in there. No matter what the number is, I'll be able to square it, right? And then add 2, no issues, any number. So how do I tell you that every number out there is okay? There's like 5 different ways to say it. You could say all real numbers. You could say the domain is. So look at my notation here. Dom F is the notation I'm going to use. Dom F stands for the domain of F. The domain of F, colon, all right? What is the domain of F? So someone said what, all real numbers? That would be okay? That just is you saying everything, okay? That means you can plug anything you want, any number you want into it.